Today, we are diving into a truly mind-bending idea. What if I told you that the fundamental laws of our universe, all the physics, might not be a random collection of rules, but instead, they all emerge from the geometry of a single, perfect mathematical shape?
All right, to even begin to wrap our heads around this, we have to start with one of the deepest and most nagging mysteries in all of modern science.
You know, the standard model of particle physics it's unbelievably successful, but it has this weird little secret. The whole thing only works because of 19 fundamental constants. Numbers that we as scientists just have to go out and measure. We know what their values are, but we have absolutely no clue why they are what they are. And just take a look at a few of them. These numbers are basically the universe's source code. They control everything from the strength of gravity and magnetism to the masses of the very particles that make you and me. And here's the crazy part. If you were to change them, even just a tiny, tiny bit, poof, the universe as we know it just wouldn't exist. It all seems so perfectly fine-tuned. But why these values? Did we just get lucky and win the cosmic lottery? Well, what if it's not luck at all? What if these numbers aren't random? A brand new idea is proposing a radical answer, and it all comes down to a kind of geometric blueprint for reality itself. So this new way of thinking is called geometric information field theory, or GIFT for short. And it basically takes our 19 magic numbers and says we don't need them. It claims that all of those constants can be calculated from scratch, with zero adjustable parameters, all from the pure properties of a single geometric object. No more knobs to turn, no more guesswork. The whole theory really boils down to two core ingredients. First, there's this incredibly complex and frankly beautiful mathematical symmetry called E8. Think of it as the foundational pattern. And second, there's a very specific seven-dimensional shape that emerges from that pattern. And here's the breathtaking proposal. The properties of this shape, its curves, its holes, its very structure, are the laws of physics. So how on earth can a shape dictate physics? Well, one way is through something called its Betty numbers, which is really just a fancy way of counting the number of holes of different dimensions in the shape. And get this, in this theory, the number of two-dimensional holes in the shape is 21. That perfectly matches the number of force fields we see in the universe. The number of three-dimensional holes, 77, which corresponds to the matter particles. The physics isn't just described by the shape, it's literally encoded right into its structure. Okay, so this is where things get really wild. What happens when you actually take this geometric blueprint seriously and start doing the math? Well, the theory starts making some astonishingly precise claims. Right, if this whole physics from a shape thing is for real, it shouldn't just give us vague ideas. We should be able to calculate those mysterious constants of the standard model directly from the shape's properties. So, does it actually work? And boom, here's the first jaw-dropper. There's a crucial number in physics called the Weinberg angle, which helps mix the electromagnetic and weak nuclear forces. For decades, experiments have measured it to be a messy decimal, somewhere around 0.231. This theory predicts it's not random at all. It's the simple exact fraction, 3/13. And the way they get this number is it's so elegant. It's simply the ratio of the shape's force holes, which we already know is 21, to its matter and structure holes, which adds up to 91. And would you look at that? 21 divided by 91 simplifies to exactly 3/13, which comes out to 0.2307. I mean, that is stunningly close to what we measure in experiments, but it's derived from pure geometry. But it doesn't stop there. The theory also says that the fabric of reality isn't just curved like Einstein told us. It also has a fundamental twist to it, a property called torsion. And the theory calculates the size of this twist to be another clean fraction, exactly 1/61. And yep, there's more. It looks at the masses of different quarks, which, in the standard models, seem totally random. This theory predicts that the ratio of the mass of a strange quark to a down quark should be exactly 20. And remember, the crucial point is that these numbers aren't being tweaked to fit the data. They are falling right out of the geometry itself. Okay, but wait a second. A shape is static, right? It just sits there. How does a fixed geometric object create a dynamic, evolving universe, with stuff that happens? Let's get into the mechanism. The idea here is that what we think of as particles moving through our familiar four dimensions of space and time is really just a shadow. It's a projection of those same particles flowing along the most natural, efficient pathways of this higher dimensional geometric landscape. The shape itself is actually guiding all the motion.
And that fundamental twist we mentioned, the torsion, that's the absolute key. Let's break it down. Just imagine this giant 7D map. This landscape isn't perfectly flat. It has these subtle twists woven into its very fabric. So as a particle flows across this map, its path is naturally bent and guided by these twists. And that bending, that guided journey, is what we perceive down here in our dimensions as physical forces and the way particles change over time.
This all sounds incredible, maybe even a little too good to be true. But a theory is only as good as its predictions. And this is where this whole idea moves beyond philosophy and becomes real, testable science. Just look at the difference here. This really shows you the sheer ambition of what this theory is trying to do. The standard model, our best theory of physics, needs us to plug in 19 numbers from experiments to make it work. This geometric framework starts with 0 adjustable numbers and instead predicts the values of 39 fundamental constants, our original 19 plus 20 brand new ones. That's a massive leap in predictive power. And this, right here, is the most important part. This is what makes it real science and not just some cool idea. The theory makes concrete predictions that can be proven wrong. For example, it predicts a very specific value for something called CP violation, which the Dune experiment will be able to test around 2030. It also predicts there are exactly 3 generations of matter particles, and no more. If the Large Hadron Collider ever finds a 4th generation, the theory's toast. It's wrong. And that is exactly how science was supposed to work. So that leaves us with this one final, profound thought. If a theory like this turns out to be right, it would completely upend our view of reality. It would mean the universe isn't just conveniently described by elegant math, but that at the deepest possible level, the universe is pure mathematical structure. The entire cosmos, in all its complexity and glory, might just be the beautiful, inevitable consequence of a single, perfect shape.